So for Module 8, please make sure you know the standard equation for each conic, which includes a parabola, hyperbola, and ellipse. If you note for the first example, I like to have a visual, so I graphed out the information they gave me. An ellipse has a center of 1, 1, so I did plot point at 1, 1 with C noted there. There is a horizontal major length of axis of 10. So what does that mean? It means that from one end to the other end horizontally will be a length of 10. So how did I know that these were the points? Well, if from one end to the other end is 10, an ellipse is symmetrical, from the center, I split it up. Half of 10 is 5, so I went 5 to the left and 5 to the right and made my points um, from 1. So I counted out 5 to the right, made a point there, 5 to the left, made a point here. Um, for formula wise, how do I know what this represents? Well, a major length of axis has a value of 2a. So in this case, 2a equals to 10. So that means if I divide both sides by 2, I know that a equals to 5, which makes sense because from the center to the end of the major axis is the length of a. And then I have a vertical minor length of axis of 6. So that means from the center, to count it off vertically should be a total length of 6. So half of 6 is 3. So that means from the center, I go 3 up to make my point and 3 down to make my point. And then these are my vertices, which, by the way, I will not be drawing this ellipse very beautifully. This is my ellipse. So these are the endpoints of my ellipse. Again, it's not going to look great. And then formula-wise, a minor length of axis, remember that the distance of B, just like A, is from the center to the vertex. So for the minor length of axis, meaning from one end to the other end, that has a distance of 2B. So 2B equals to 6. I'm going to divide both sides by 2, and B equals to 3. So to find the values of A and B, remember A and B are from the center to the end. For A, it's the center to the end of the major axis, and for B, it's the center to the end of the minor axis, meaning the smaller length. So now that I have those, I actually have everything I need in order to write my equation. I'm just out of room, so I'm going to put it up here. So if I look at the equation of an ellipse with a major horizontal axis, it's going to be x minus h squared over a squared. Keep in mind that a is the larger denominator, always in an ellipse. And since this is a horizontal major length of axis, the a or larger denominator should be under x, plus y minus k squared over b squared equals to 1. Now, just like in any function, like linear function, quadratic function, like parabola, anything like that, we leave x and y as they are. Why? Because x and y represent any point on this ellipse. So we leave everything in terms of x and y. So that means I need to fill out h, k, a, and b. So my center is an xy point, but it's a special xy point. So it's labeled as h and k. So knowing that, I'm going to just fill in my numerator. And we've already solved a and b. So since I know a is half of the major length, that would be 5 squared. And b, which is 3 squared. And yes, you can rewrite it as x minus 1 squared over 25 plus y minus 1 squared over 9 equals to 1. Now, for the next one, I'm eliminating the parameter. The parameter is known as a third variable. Sometimes it'll be noted as theta. In this case, it's t. So just to follow the steps here, I isolate t in the x function because I'm going to write y as a function of x. So when I'm done, it should say y equals to something in terms of x. So because of that, the first step, I'm going to isolate t in this first function given to me in terms of x equals 2. So x equals 2t plus 1, subtract 1 on both sides. I'm going to get x minus 1 equals 2t. And then to isolate t, divide both sides by 2. So from here, I'm going to substitute that value into t for the y function. So I'm going to bring down this y function, y equals 3. Instead of t, I'm going to replace t with what it equals to, which is x minus 1 over 2 minus 5. And then from there, you can play up the algebra. So you can split up the numerator, give each one its own denominator of 2, which again, I'm a little out of room here, so hopefully this will all fit. And then from here, distribute the 3. So that'll give me 3x over 2 minus 3 over 2 minus 5. And you have two constants at the end, so you're going to combine negative 3 over 2 minus 5, which will give you negative 6.5. Change that into an improper fraction, and that will be y equals, I'm going to put that up here because I'm out of room, y equals 3x over 2. Negative 3 over 2 minus 5 would give me negative 13 over 2. All right, guys, I hope this helps.